this.
So, guys, the biggest thing with 6-5 is getting the key concepts of product, quotient, and powers. As long as you have an understanding of how they work, that's going to be what's key, especially in solving. Yeah, log base b of m times n is the same as log base b of m plus log base b of n, and being able to go from one to the other. Or the fact that log base b of m divided by n is the same as log base b of m minus log base b of n. Or lastly, log base b of m to the n is the same as n log base b of m. And we'll use these especially when solving, and more going to a condensed form, because we'll have it as one of these and we want to make it as a single log. Now, we won't be dealing with solving of these types today. What we're going to look at first is the property of equality for exponential equations, or as I like to call it, 1, 2, 1, one-to-one property. And what this property states with exponentials is if we have two exponential equations equal to each other and the bases are the same, b to the x is equal to b to the y, is true if and only if x is equal to y. So for us, when we look at this first one here, 5 to the 3 minus 2x is equal to 5 to the negative x. Well, the only way that these two equations can be equal with the base of 5 is if 3 minus 2x is equal to negative x. If the bases are the same, the only way they can be equal is if the exponents are also the same, or also equal. Now we just need to solve for x. Yes, we'd add the 2x. We'd want to move it. Because here, negative 2x plus 2x is 0, leaving us with 3. Negative x plus 2x is, so 3 is equal to x. Because as long as the bases are the same, the exponents have to be the same as well. And one other thing is that we can only have one base or one on either side. So here we have 6. We only have one on either side of the equal sign. So the bases are the same. So it's telling us that negative 2a has to equal to minus 3a. So we'd add 3a to both sides. And if we add 3a to both sides, we get a is equal to 2. Now with any of these here, if we're not sure that we got the correct answer, all we've got to do is plug it back in. So for this one here, we can say 6 to the negative 2 times 2 is equal to 6 to the 2 minus 3 times 2. Now 6 negative 2 times 2 is negative 4. Negative 3 times 2 is negative 6. 2 minus 6 is negative 4. 6 to the negative 4th is the same as 6 to the negative 4th. We get this here. Now we could have also plugged it into the calculator. 6 to the negative 2 times 2 is this decimal here. On the other side, we have 6 to the 2 minus 3 times 2. It gives us a decimal answer, but the decimals are the exact same. So that is the correct answer. Questions on any of these here? Any questions on anything we've done so far? Are you ready for the next one? Okay. 3 to the 2a is equal to 3 to the negative a. Well, the bases are the same, so the exponents must be also. So we have 2a equals negative a. So we need to move the a over, and then yes. So we have 3a is equal to 0. At this point here, we can divide both sides by 3, telling us a is 0. And that's it. Questions on this here? Let's look at the next one. 2 to the 2x plus 2 is equal to 3x. So here we're saying what? 2x plus 2 is equal to? So x is equal to 2. That's it. Questions on any of these here? Now let's look at the next one. We have 6 to the 3m times 6 to the negative m is equal to 6 to the negative 2m. Well, on the left-hand side, we do have 2 6's. On the other, we have 1. Well, for the base, this 1-to-1 to work, we need one base on either side. Now, we do know if we multiply like bases together, we add the exponents. So I can rewrite 6 to the 3m times 6 to the negative m as 6 to the 3m plus negative m. Is whenever we multiply like bases, we add the exponents. Well, we can simplify that. 3m plus negative m is 2m. So 6 to the 2m is equal to 6 to the negative 2m. Well, the only way these bases can be the same and these two equations be equal is if the exponents are also equal. And from here we can either way, because we can subtract 2m or add 2m. Either way works. If we subtract 2m, we get 0 is equal to negative 4m. If we added the 2m, we would get 4m is equal to 0. At this point here, we can divide by negative 4. If you had a positive 4, you would divide by 4. But either way, we still get that m is 0. And we don't have to worry about signs because 0 is neither positive nor negative. It can be positive or negative. It actually works out 0 is also not even or odd. 0 is neither positive, negative, even, or odd. It's just 0. Any questions on these so far? We ready for the next one? So if we look at this next one here, 4 to the 2x times 4 to the x. Whenever we multiply like bases, we add the exponents. So it'll be 4 to the negative 2x plus x is equal to. Well, we could put 64, but we really need it as what? 4 to a exponent, yes? 4 to what power is 64? 4 to the 4th? 4 to the 4th, we can plug it in and check is. Third is 64. So we can rewrite 64 as 4 to the 3rd. And all the ones we'll be dealing with in here, or for today, are going to be rewritable. So 64, we can rewrite it as 4 to the 3rd. And the reason we do that is because now we do have one base on either side, and they are the same. Now we can simplify the left-hand side a little bit. So 4 to the negative x is equal to 4 to the 3rd. Or really, we can say that negative x is equal to 3. Divide both sides by negative 1. Tells us x is equal to negative 3. And we could plug this in if we want, say 4 to the negative 2 times negative 3 times 4 to the negative 3 and see if we do get 64. 4 to the negative 2 times negative 3 times 4 to the negative 3rd is 64, like we wanted. Any questions on any of these here? Let's look at the next two. Now again, all the ones that we're doing today, and I said this already with these here, we can make the bases be the same. Now, if we look at the first one, we have 100 to the x is equal to 1/10 to the x minus 3. Well, I can move the 10 from the denominator to the numerator. But if I do that, I have to change the exponent from positive to negative. So 10 to the negative 1 is the same as 1 over 10. These are the same. Is there any way I can write 100 as 10 to an exponent? Be 10 to the, because 10 squared is 100. Now do both bases, are both bases the same? Yeah. Because they're both 10. We do have to simplify the exponents a little bit, but the bases are the same. Because here, 2 times x would be 2x. The other side, we're going to have to distribute the negative 1, giving us negative x plus 3, which exactly is going to tell us that 2x is equal to negative x plus 3. First thing we can do is I would add x, because on one side we do have x by itself. So that'll tell us that 3x is equal to 3. Any questions on how we did this here? Let's look at the next one. What would we rewrite both of these as? 9 squared to the x and 9 to the negative 1. Now, 9 for this one isn't the only one we could use. We could use 3 technically, because 3 squared is 9. But 9 works just as well, because as long as the bases are the same, that's all that matters. So we get 9 to the 2x is equal to 9 to the x minus 3. Because we multiply the negative 1 with both x and 3, giving us negative x minus 3. On the other side, we have 2x. Now, this is also telling us that 2x is equal to negative x minus 3. The next thing we would need to do is add the x. Tell us 3x is equal to negative 3. And then we would exactly x is equal to negative 1. And that's it. Questions on any of these here? We'll look at one more of these here, and then we'll move on to the next type. So here we have 3 to the 1 minus 2x is equal to, well, we really want 243 to be 3 to a power. What power do we think 243 would be to?
I'm saying 6.
Fifth. So once we find that power, now we just need to set the exponents equal to each other. 1 minus 2x is equal to 5. Yes. And then and that's it. Any questions on this here? You ready for the next piece? Some more challenging stuff. If b, x, and y are positive real numbers with b different than 0, then log base b of x is equal to log base b of y if and only if x is equal to y. If the logs are the same, then what's inside the logs has to be equal as well. So if we look at the first one here, the natural log of 4x minus 7 is equal to the natural log of x plus 5. We only have one log on either side, and it is the same log, same type of log. It means that what's inside has to be the same. So we're saying that 4x minus 7 has to equal x plus 5. Now we just need to solve for the value of x. So 4x minus 12 is equal to, then we can subtract 4x, minus that. And last but not least, we would divide by that negative 3. That tells us x is equal to 4. You knew what you were doing, just
Yeah, I always mess.
say the wrong thing. Questions on this here? Now, the same thing is true with the next one. Since the natural logs are the same, what's inside them exactly we can add. So 7x is equal to 2x plus 15 minus 2x. 5x is equal to 15. Divide both sides by 5. So x is equal to 3.
But I feel like once I hit the page, mine will be wrong.
Questions on any of this here? We'll go on and do this one here, and then we'll look at the next one. Natural logs are still the same, so what's inside them have to be the same as well. First thing we can do is we can subtract 2 from both sides. Tell us that 5x is equal to x plus 8. Then we would minus x, telling us 4x is equal to 8. Now with logs and natural logs, we do have to be careful and make sure what's inside the log when we plug it back in. Not so much the value of x. Would not make either one of these be 0 or negative. So if we plug 2 back in, 5 times 2 plus 2 would simplify to the natural log of 12. Since the number inside the logarithm at the end is a positive number and not 0, that's fine. We can do the same thing with the other side. It's positive, not 0, and they are the same, so it works. Now, if it turned out, and this is not the case, that they were both negative 12, natural log of negative 12 is equal to the natural log of negative 12, even though that these would match, because there's a negative inside the log, it doesn't work. It's not true. Even though we do have the same statements, it's not true because we cannot have a negative or 0 inside of a logarithm. It just doesn't work. Questions on this here?
For the next one, will we just get 5x?
Yes. Because it doesn't matter what the logs are as long as they are the same. Right, the 2x telling us and that's it. Questions on any of this here? And that's it.